share with us insights about the 3D content in mixed reality. So please welcome Sofia Gonzalez from Microsoft with an introduction to 3D content in mixed reality. Oh, I'm so sorry.
Hi, everyone. My name is Sofia Gonzalez, and today I'll be giving you an introduction to 3D content in mixed reality. So many of you have seen this device. If not, it's called the HoloLens. It's actually a face computer. Amazing, right? Well, I designed experiences for it. So by the end of this, my goal is that you understand the right column. So you will understand what's a 3D model, what are triangles, what do you optimize, and how you go from CAD to GLB. But don't worry, I'll explain all of this today. But first, I want to tell you my story, how I got into this world. I came from Mexico to Microsoft 3.5 years ago. I actually was designing experiences in the entertainment business. We were doing a stream music application. So I was getting paid to listen to music and do experiences that I would like as a consumer. It was paradise. But as it often happens in corporate America, a reorg happened and priorities shift, which it's okay. And I landed in a group called HXT. And they told me that I would be designing experiences for the face computer, HoloLens. I was so nervous since I knew nothing, nada, niente about AR and VR. I was like, what? It's AR? What's that acronym? What's VR? Why, do they exist? Why would people want to put these computers on their face? I didn't know what I was doing. So I started by asking my fellow new colleagues that what's actually mixed reality? And the great thing about innovation is that people are super passionate about it and want to tell you about it. So they actually told me that it is blending the physical and the digital world together. So I was like, okay, that's not too bad. It's as if I'm in this real world and I see some different user interface popping in and out. It's like, okay, I think I can get into it. I'm understanding. So from there, I landed in an application called Dynamics 365 Layout. Here's a video of it.
Across all industries, transformation is key to growth, and designing new spaces involves detailed planning. If you aren't prepared, the smallest oversight can cause costly delays. With Layout, you can plan your space, collaborate with others, and experience your designs with confidence in mixed reality before you build with an immersive experience. Visualize your layout in 3D. Try new ideas and iterate quickly. But even with the most detailed planning, the real world can present unexpected challenges that require creative problem solving. With HoloLens, you can work with high-quality 3D holograms integrated into your space. With Layout, you have the tools you need to design and review in context and find new solutions that give you confidence before you commit. Transform your layout in moments with precision and speed. Share your designs with others.
Do you have time to take a look at this floor plan?
All right, let's have a look.
And save time by making decisions together.
Great. Thanks for the quick work.
With Layout, you can design faster, share your work with others, and experience your designs in mixed reality, so you can break new ground with confidence.
So as you can see, with this application, 3D models help you visualize your object in the context of the physical space. This helps you not only in manufacturing, how we were doing it, but also in your day-to-day. Since, like, for example, if you want to buy a new couch, but you don't know if you can do the three cushion one or the two, you imagine if you have a hologram and you can see what kind of sofa fits in your living room. It's amazing, right? You save time and it gives you new ideas on the fly. So I was very scared to start designing in the actual 3D world. And I volunteered to design the PC app. The PC app we were using to transfer the actual models you wanted to have in the HoloLens. And so I thought, I can do this. I've been in the industry for a lot of years. I understand 2D, I understand UI, no brainer, how to transfer a file. But oh boy, was I just wrong. In order for a 3D model to be a hologram, which I thought is super simple, it's not that simple. It actually has to go through so many loops and many things in order to actually become a hologram. And I did not know that I was getting myself into the biggest technical problem our studio had, and I was the least technical designer the studio had. So yeah, I was like, what even is optimization? What's poly count? What are the number of objects in the scene? Why would you have a scene? And then finding out that that's the biggest adoption blocker for all of our applications, I was like, this was on me. I was like, how did I land on this? And how I started to solve it was, okay, you know that you just have to transfer a file and it's a type of file format. Well, let's ask actual customers how they deal with this. And so, yeah, we found out that 3D models are very important. If you don't have your personalized 3D models, then it can lose some value in the mixed reality. So let's go over a scenario. You are working on Factory X and you are one of the engineers. You have this amazing idea of this machine that can actually change how the assembly line works and save money and produce more to the company. Well, great, right? But if you can visualize it to see if it will fit, since manufacturings have a lot of safety rules that they have to go through, and it's a very long process to actually change one part in the factory floor. So if they can just visualize it and see if it will work or not, we can save them so much amount of time, which at the end saves a lot of money. Like factories, for example, usually just shut down twice a year their factory to optimize the assembly lines. They cannot afford to shut down them. So as well as having that, imagine if you can have that artifact and share it with the stakeholders to convince them like, hey, this will actually work. This would be amazing for them. And that's what we heard. Our customers said that their personalized 3D models are actually essential for their mixed reality experiences. So great. Now you understand why 3D models, why are they important, how I got into them. Well, now let's actually go down into understanding them. There's a lot of 3D content out there that you can start from, but today we're going to concentrate just on the 3D model. So for example, I'm going to give you how I managed it. Since I was going from 2D to 3D, I'll give you my list from going how to 2D to 3D. So in the 2D world, for example, if you go to Photoshop, at the end of the day, your output is an image, correct? Well, here, imagine that the output is a 3D model. So whatever tool you're designing with, which can be a CAD product, the end of the day, that output will be a 3D model. Same as like the output, it's an image in the 2D world. Great. So now that, now this guideline that I created with other colleagues will help you curate your hologram. First, we'll go through the CAD, and I'll go a little bit at a time. You have to select a tool that creates 3D models, and these are just a few. There are much more, like Vectory as well, besides the AutoCAD, Inventor, Navisworks, Creo, there's SolidWorks, SketchUp, CATIA, even with Cinema 4D from Adobe, like there's so many tools out there that you can start from. There's not one that's better than the other one. Well, if you want to see your industry. And so from there, let's think about video. Let's think about the vectors, right? So in the 2D world, you actually go from a vector to create something, right? So same here in 3D, you go from vector. So you connect up some points that close into something, and then it extrudes. So just the same as how you start in 2D in Illustrator, Sketch, or any other tool, you end up doing this in 3D, and then you just like close it into a solid. So, and it creates a volume. So it's not too bad, right? It's easy. And this tool, it's from Vectory. So now that you understand how you can create which tools to use, this is a very important thing that will affect the holograms, the rendering time, which is actually the display time. So just imagine how it's the amount of time it takes to bring it into your screen. So just like how the movies, like 10 years ago, when we didn't have great Wi-Fi networks on the go, imagine that you have this big image or big movie that you're trying to see, but the internet is low, so it goes like one by one. So just imagine like that with 3D models. If you have very high-end resolution, it's going to take time to download it. So it might not be a great experience for the end user, depending what you want at the end of the day. And so now that you understand what the rendering time is important, I'm going to tell you why. Now that you have your tools, you have to think about the platform where you will see this 3D model. Is it a smartphone? The smartphone actually can handle mid-resolution. Is it a HoloLens? The HoloLens is actually a smaller computer than a smartphone, and that can handle the lowest resolution of a 3D model. Or is it an immersive headset? This one can take that biggest one since it actually uses a big hardware computer, right? So performance is really important in order to understand the resolution and the amount of time. So the building blocks of our 3D model is, just as like in 2D, you have layers that end up creating an image, right? Here, polygons create the 3D model. So that's why you will hear this word very often, polygons. At the end of the day, they're those squares that create the 3D model in the volume. But if you go narrower, the polygons, which are squares, are divided into two. So what do they create? Triangles. So just think about how in the 2D world we have pixels, the 3D models have triangles. So this has to take into account because the more triangles, the more resolution, which looks better. So imagine if you have a sphere with a lot of, you have to have a lot of triangles to make it a surface, a very thin surface in the circle. But if you have less triangles, the circle will be clunky. It won't have that surface, right? So that's why, let's think about triangles. So now that you really understand how 3D models are composed of, let's go to the next one, optimization. So with Saving for Web, a long time ago, when the web could not handle big resolution, we would have actually this in Photoshop that you would compress it and save for web. So same here with optimization. Optimization is that compression. So actually removing resolution to it. So in Save for Web, you remove pixels, and here you remove triangles. And now I will go through the criteria that you need in order for this optimization to work for your display time. First, triangles. Again, I know this will be the repetition. You can start from a CAD file, right? And as you look in this image, on the first one, it's beautiful, right? And then you try to optimize it like half. So here, for example, the middle one, it's a 52,000 triangles, but this is still too big for a HoloLens. So now we have to even remove more triangles, and now at 9,000 triangles, we would take that. And as you can see, it gets a little clunky, but at the end of the day, when you're doing holograms, it's more around like seeing it in context versus having the highest visual fidelity. So the second one is the number of individual objects. So the more objects you have in that 3D model, it's going to take more time to actually talk to the computer being one by one. So imagine you create this table. So you start with one leg, another, and another. So you have 4 legs, right? Then you put a tabletop. Well, if we just bring it like that, it's actually 5 objects since you have the 4 legs and 1 tabletop. So it's going to talk to 1 leg, then bring another leg, and then bring another one, and then the tabletop. So we don't want that because it's taking a lot of rendering time. So what we'll do is just create it in a solid. So let's just say that, let's stitch it all together and create it as one object. That would actually minimize the rendering time. And the third criteria, which is the most important one, it's the number of unique materials. This is such a complex topic that I'm not going to get into it. But as you can see, the less materials, the better. Same as like the less objects, the better. So let's say that same table, you have the legs out of wood and then the tabletop out of granite. Well, what if you just created all of them out of wood? That would actually just call one material. And here, for example, this image created by one of my coworkers, Ronnie, you have actually a sheet that has all the textures in it. So instead of having multiple like PNGs to go talk to grab the textures, it just calls one. And it actually minimizes the rendering time. And all of this you can do in the same tools that I had proposed to start with. And so as you can see, if you go from high to low, yes, you lose details. Yes, it's more pixelated or triangulated, but at the end of the day, it is what you needed, just to see the actual measures, and it gives a glimpse of how it will be. So for example, here, the chair on the left is the high detail, it has stitches, but here the one on the right has less, but it just can still define it's a red chair. And you can still see the curves, so it works, right? And now the last step, convert. So just how in Photoshop, the output, it's an image, you have to have a PNG, right? Because you don't open the Photoshop file everywhere. Here it's the same with CAD to GLB. GLB actually is just one of the many standards there are for 3D models, but it's the one that in Microsoft we're trying to standardize. This GLB acts as a zip folder that has a geometry, the polygons, and the materials inside it. So imagine that it's, just like a zip file with a limit of data on it. And it works really well. And that's what we've been using for the HoloLens and also for the smartphones. So now that you understand how to create the hologram, the 3 main criteria, let's go, but what do you do next? How do you actually upload it, right? So you can either choose your cloud base and opening the cloud in your platform, either in smartphone or in your HoloLens, or you can plug it into your computer and transfer it from local file to local file. One of the products Microsoft has that my colleagues work with, it's called Product Visualize. They actually have it on the cloud, and they use the dynamics for sales to bring it in. That's pretty cool, huh? And then the app that I was talking about, Leo, the one that I got to design, actually uses the USB. Why? Because manufacturers usually don't have a good, really Wi-Fi, so they cannot bring it down. So what do? Just have it in their local file. So if you use the import tool that I designed, and you connect your HoloLens, you click send, it automatically goes into your HoloLens. And now you can actually open the app and see your file there. So as you can see, it's also very simple. And it just went from your local drive into the local drive. But we were able to read the 3D models. So what did we learn today? 3D models are complex. And there's really not a lot of standards on this. This is new, this is innovation, what we're doing right now. So it's up to us to start defining the standards and help each other out. This will still be ongoing. I don't think this process that we've made is the best one. I know there's gonna be much more in the upcoming future. And so, Remember that you just start from your CAD and you have to reduce the resolution by optimizing it, and then you have to convert it. The standard that we use Microsoft's GLB, but there are many others, and this creates your hologram. Oh shoot. Okay, and so yeah, so remember platform first. If you want higher fidelity, you have easier typing. If you want a hands-free experience, then you have a real-world experience. And if you want to immerse yourself, you can use the highest fidelity with the VR headset. And I hope that my analogies help you out as they help me. Thank you.
Hi, thank you very much, Ana Sofia. Thank you for your presentation. So we have some time left for a really short Q&A. So Benjamin was asking, what are your go-to software packages for each step going from CAD to holograms?
Yeah. Hi, Giovanni. Thank you so much.
Hi.
Yeah, so there's many tools there. What we were using with my colleagues, I was doing more of the UX of the process, and my colleagues were doing the 3D artists most of the work. But they would use Maya and Blender. Blender, it's a very easy and free tool that you can use to optimize. Mm-hmm.
Okay. And then a last question, Lisa is asking, why do you call 3D models a hologram? Well,
oh, this is such a complex topic. Yeah, everybody has their own taxonomy, but for us, at the end of the day, you have to start with a 3D model to create a hologram. And the hologram is just how you see it, what we were using at that time in the HoloLens, but you can use it as well in the mobile or in the VR headset. And yes, it's just like having a 3D object at the end of the day. We call it hologram because you're in an augmented reality with mixed reality device.
I remember a friend of mine in one of the first augmented reality conference I've been in. He was a philosopher, and he actually demonstrated epistemologically that augmented reality content is real. So please get in touch with me, and I will be happy to provide the paper that certifies that holograms are reality. So thank you very much for being with us, Ana Sofia. And I invite all our guests to get in touch with you for further questions and discussions and networking. So thank you very much. Bye-bye.
Thank you.